Okay, so in conclusion, let me see here. I think I'm just gonna let you see what I wrote here. We finished taking the derivative. We found that limit, we took the derivative of the numerator, the derivative of the denominator. Things canceled out, and we found that the limit as x goes to infinity is equal to 2. Now we're ready for step 3, and step 3 was essentially to write that the limit of e to our exponent is the same thing as e to the limit of our exponent, which we just calculated is equal to 2. So our answer up here, let's see here, maybe we can put it in a big red. Our answer for our original limit was that our limit is equal to e squared. And the reason why this example is really important is because even though we started out with an indeterminate form of 1 to the infinity, lots of times students say, oh, that's equal to 1. No, 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 no. You have to apply L'Hopital's rule, because you could get 1, you could get infinity, you could get e squared, right? So you don't know what you're going to get. That's why it's called an indeterminate form, because it's not determined. It depends. Okay? And we have one last example. I'm going to try to do this one last example. The one last example is down here. It's kind of hard to see. Maybe I can just rewrite it. But I don't know why it's... So let's cut. So I would like to be able to have enough space to do it. So let's add a page below. Paste. Okay, so here we go. We need the limit as x goes to 0 from the right of 4x plus 1 to the power of cotangent of x. So in order to do this, we need to know what is cotangent of x. Cotangent of x is cosine of x over sine x. Okay, so let's do our initial analysis. So 4x plus 1 to the cotangent of x. Now this is a limit as x goes to 0 from the right. Now as x approaches 0 from the right, 4x plus 1 is going to approach 1. And what about cotangent of x? Well, as x approaches 0 from the right, sine x is approaching 0, cosine x is approaching 1. So, and let's see here, sine of x looks like, so this is a quick sketch. So if x is approaching 0 from the right, then sine of x is approaching 0 from the right, but sine of x is positive, right? So we'll have positive divided by a positive. So this will be approaching plus infinity, okay? And if you don't remember how to figure out if your limit, infinite limit is plus infinity or minus infinity, check out the video on infinite limits, okay? And the reason why you need to check that out is because you might be in a situation where this is, you don't know if it's plus infinity or if it's minus infinity, right? So, okay, so we've got our indeterminate form, which is going to be 1 to the infinity. And we already know how to deal with this because we've seen a couple of examples. What we're going to do is we're going to use that old trick of rewriting the function as e to the log of the function. So let's go ahead and go. Okay, so we'll have step 1. 4x plus 1 to the cotangent of x is equal to e to the natural log of 4x plus 1 to the cotangent of x, right, which is equal to e to the cotangent x times natural log of 4x plus 1. That's step 1. Now step 2 is going to be to compute the limit as x goes to 0 from the right of our exponent, cotangent x times natural log 4x plus 1. Now, let's try to take a look at what we have here. So as x approaches 0 from the right, natural log of 4x plus 1 is going to approach 0 because 4x plus 1 is approaching 1 and natural log of 1 is equal to 0. Okay? And for our cotangent of x, which is cosine over sine, so we can rewrite this as cosine of x over sine x, we know that the sine of x is going to approach 0. Okay, and then the cosine of x approaches 1. So our numerator is approaching 0, and our denominator is approaching 0, so we can apply L'Hopital's rule. So our limit as x approaches 0 from the right of cosine x, natural log 4x plus 1, divided by sine x is equal, according to L'Hopital's rule, to the limit as x approaches 0 from the right. Now in the denominator, we'll have the derivative of sine x, which is going to be cosine x. In the numerator, I need the derivative of cosine x times natural log 4x plus 1. So I need that derivative. Okay. So I'll take the derivative of cosine x, which is negative sine x times natural log 4x plus 1, plus cosine x times the derivative of natural log of 4x plus 1. So that'll be 1 over 4x plus 1 times 4, right? Using my chain rule. Okay, so let's rewrite this so we can see it better. So we have the limit as x approaches 0 from the right of, what do we have here? So we've got negative sine x times the natural log of 4x plus 1 plus cosine x. We've actually got a 4, so 4 cosine x divided by 4x plus 1. And all of this is divided by cosine of x. So let's see what happens as x approaches 0 from the right. So cosine of x is going to approach 1. Sine x is going to approach 0. Natural log of 4x plus 1 is going to approach 0. Cosine x, this is going to approach 1. So 4 cosine x is going to approach 4. And 4x plus 1 is going to approach 1. So we end up with this limit equal to 0 plus 4 over 1, which is just 4. Good. I'm really glad that we didn't have to take to apply L'Hopital's rule yet again. Okay. So let's see here. So now we're on step 3, which is to say that our limit, so our original limit as x approaches 0 from the right of 4x plus 1 to the cotangent of x is equal to the limit as x approaches 0 from the right of e to the cotan x times natural log 4x plus 1, which is equal to e to the 4, right? Because we computed that the limit of that exponent is equal to 4. So the limit of e to that exponent is equal to e to the 4. So that is our answer, is e to the 4. So we again have a situation where our indeterminate form was 1 to infinity. And our limit ended up being e to the power of 4, right? So e to the power of 2, e to the power of 4. You just never know what you're going to get. So that's why it's important to apply L'Hopital's rule. Thank you.